This conference will now be recorded.
Hello, good morning. Welcome back. Yeah, today we are going to discuss about roles and responsibilities. Yeah, as a DevOps engineer, so what is our role in real-time projects? Right, what we will do, tool-wise, what are the activities we'll be having, and what are the challenges we face in real-time projects? So we'll try to understand. Yeah. So before going to this, anyone having any questions on Azure? In last session, we discussed about Azure snapshots and IAM, also storage, right? So anyone having any questions on that? Fine. So these roles are
I have
very
question,
important.
but I have post in group.
You post in the group.
Yes, sir.
Same question, right? Yesterday you asked me. Same question or
Yes,
any other
yes.
question?
Same question, sir.
I make you as a presenter. Can you show me quickly?
Sir, right now I can't share. I will share on group
No. Fine. No problem.
because laptop has some issues, sir.
Okay. Fine. No problem. Yeah. So responsibilities and roles in DevOps, right? Yeah. So day-to-day activities for DevOps engineer and team. What are the activities we perform in real-time projects? Okay. So this is very important for freshers and non-IT guys, even though experienced guys, because when we switch to DevOps role, so internally within the project or else externally, when we switch to DevOps, so what are the roles? What roles we have to perform, right? So what activities, daily activities, and also what are the challenges and the tool wise, we'll try to understand now. Okay. Yeah, very first thing here, make sure that the pipeline is running smoothly, right? And next one, interaction with other teams. As a DevOps engineer, what are the teams available? What teams we have to interact with? Work on automation backlog. What is backlog? What are the activities? Automation. Yeah. And infrastructure management. So as a DevOps engineer, how can we manage the infrastructure, right? Dealing with legacy stuff. What is legacy stuff? Yeah. Monitoring and removing bottlenecks. What is bottleneck? Problems. Yeah. Showstopper. Yeah.
So what is automation backlog?
Yeah, we'll go one by one. Yes, I'll show you. We'll go one by one. Right. So documentation and training and self-development. So these are the very important things. So let us go one by one. Right. Yeah. So very first thing, which is make sure that the pipeline is running smoothly. What is pipeline? Upcoming activities, what we are going to do in the future. We normally say as pipeline, like down the road, planning something in the next 6 months. Normally we do that word, right? Those are the pipeline. That is pipeline. That is okay. But what is THD pipeline? Yeah, I'm talking about CHD pipeline. Yeah, your pipeline is correct. I understand that. So pipeline activities you are saying, upcoming activities, right? Yeah, fine. See here. So this is the pipeline, right? So basically in real-time projects, as a DevOps engineer, so what we will do, we have to handle these pipelines. So every project team, they configure this pipeline. So our role is integrations and maintain these pipelines, right? So we have to install some plugins. We have to install plugin updates, right? So for example, when we are trying to pull the code from version control, GitHub to Jenkins, sometimes what will happen? Jobs will be failed, right? So when we deploy on production servers, when we deploy the code on production servers, jobs will be failed. Sometimes communication will not be happened with the application servers and Jenkins, application servers and other tools, right? And source control system, source code management, and Jenkins. The communication will not be happened, right? So this pipeline should be running smoothly. So this is our responsibility, right? So code will be available in version control, and we build the code, test the code, deploy, auto test, deploy to production. These are the stages, right? So normally developers will develop the code in their local workspace, local Git, right? So once development is completed, testing is completed, they will push the code to remote repository. From remote repository, CI/CD will pick that, which is Jenkins, right? We'll take that and we'll take the help of manual, convert it to WAR file, jar file, ER file, whatever file. So based on the application, and it will push to application servers or else Tomcat server or any web servers. There we deploy the code, right? So until the code is deployed, so this pipeline should run smoothly. That is our responsibility, right? So if the code is not deploying, code is not pulling, code is not pushing, so definitely developers will communicate DevOps leaders. So we have to involve into that activity. We can check the activities, why this is not communicating, what are the issue, right? So we have to involve into the activities. So normally, what are the issues we face in CI/CD? What are the issues we face in CI/CD pipeline? So most of the time, jobs will be failed. While pushing the code, pulling the code, jobs will be failed. Why the jobs will be failed? What are the reasons here? For example, I want to pull the code from GitHub to Jenkins. While pulling the code, the job is failing, keep on failing. What is the issue? It may be goal issue, it may be communication issue, it may be network issue, it may be GitHub is in maintenance activity, right? Or else, whatever plugins we install in Jenkins, those plugins will have some updates. If you are not updating that updates, jobs will be failed. Patches will be released, right? I showed you last time. That patches we have to install monthly. Plugin patches. If you are not installing, plugin will not work properly. That is why. So make sure the plugin should be updated every month, right? So these are these type of issues, common issues will get, right? And also sometimes what will happen while deploying the code on production, by the time of the job will be failed, right? So due to some security issues that will be happening, security layers, okay? So these are all things we have to check. So while when we get into the project, we get all the KT, what are the environments we are using, what are the environments available, how many deployment servers available, production servers, how many test servers available, how many UAT servers available, what is source code management control. So only we have Git RS, SVN, RS, TFS, T Foundation server, right? Everything will get information. So when we get into the project, so after that, the CI/CD, so we have to handle with proper plugins, proper security layers, proper so everything we have to check stage by stage, right? So when we configure CI/CD, when we configure this, so 99.99% it will not give any trouble, it will not give any issues, but 1% chances are there. Sometimes pipeline will be broken. This will be sometimes it will be happen by the time you have to involve in the activities, right? See here. So this is the pipeline. So here we have source code management. So we commit the changes, right? After that, pull request. Pull request will be there. We pull the code and we push the code. This is CI pipeline. This is CD pipeline, right? So what is CI/CD full form? Continuous integration, continuous delivery is the Jenkins. Continuous deployment also there. which is Ansible. CD means continuous delivery, also continuous deployment, right? So continuous delivery is a Jenkins, continuous deployment is a Ansible, right? See here. So build, test,
Continuous
sonar,
delivery.
security.
What is continuous delivery?
Yeah, Jenkins is a continuous CI/CD tool, right? Continuous integration, continuous delivery means what it will do, what Jenkins will do.
No, after Jenkins, you said which tool you used?
The production servers normally. After Jenkins, we use production servers to deploy the code. Tomcat or web server or JBoss server, web space server will be there, right? That will be covered in first project. How to deploy the code on Tomcat server, that we will discuss. How to create server, how to log into the server, Tomcat, how to deploy the code on Tomcat, that we will see. So tomorrow we'll work on that, Saturday, right? So this is a pipeline should be running smoothly. That is our responsibility. We have to handle this, right?
Ram,
Yeah, go ahead. Yes.
what is blast radius?
What is last?
Radius,
Block radius. Just Google it.
blast radius. We can see in
Where you,
the
where you found that?
in the slide in the
Okay,
slide.
okay. I see. See here. Yeah, basically this flow will be happen like this. So dev QA stage production. These stages will be more like this. Blast radius means so the flow will be more like this. Simply can understand. So this symbolically they gave something here, but this is not not particular activity. So this is a flow. Simply can say flow. Okay.
The CA platform, they have this testing, right?
Yes.
That is unit test.
Unit test cases. Dev tape, yes. And also we integrate Sonar here. Sonar. Once test Git level, it will be happened. So CA level testing will be happened. And the Sonar is a tool. It will mean, yeah, we create some metrics in the Sonar. We means developers. So DevOps here will not have any access on Sonar, right? In Sonar, normally developers will create metrics. So how many duplicate lines are there? Like more than 3 lines are there, more than 2 lines are there, duplicate lines are errors. So it will not accept to the next level. It will not allow to the next level. Right? So next one, interaction with other teams. What are the teams involved here? What teams? Yeah, we have to coordinate with which teams? What are the teams? Most of the time we connect with the developers, development team, and also testing team sometimes, and operation team also. See here? So as a DevOps engineer, we are in middle. So we have to coordinate with all the team members like this. So developers, testers, operations team, right? So developers always communicate with us. They will give you some requirement. They will take some inputs from our side, right? So whenever they want to build the code in sequential manner, like build after other projects are built. So by the time they give you information, so as per their requirement, we can configure the jobs, you can build the jobs. And also quality assurance team, testing team, they will communicate with us, right? So while pushing the code, before pushing the code, they will test the code, right? And operations team, so they will maintain this infrastructure operations and all. So we have to maintain DevOps here also involved, but if we have any operation team separately, so we have to coordinate with them. So currently DevOps engineers will maintain the infrastructure also, but so some of the companies, very few companies, so operations team is separate team is there, right? So most of 80% of the companies, they are not having any operations team. DevOps engineer will maintain the operations also, right? So as the DevOps engineer, we have to coordinate with developers, testers, operations team. Fine. Next one, work on automation. So when we talk about automation, right? So we have automation tools like Ansible, Chef, and Puppet. So currently, Puppet and Chef we are not using in real-time projects. Chef and Puppet. So we are using Ansible. Most of the project teams they are using Ansible, right? So in Ansible, what are the roles we perform? What are the roles and what are the challenges we face in Ansible? We'll try to understand. So in Ansible, what we will do? We do automation, we run the playbooks, we troubleshoot the issues, right? So here in Ansible, we prepare the playbooks and we trigger the playbooks when we want to perform any activity. So by the time, what will happen? When we run the playbook, when we build the playbook, what will happen? For example, 1,000 servers are there, right? Yeah, when we run the playbook, 995 servers are deployed. So for example, I'm deploying Java, right? So five servers not deployed. So yeah, we are getting some like unreachable, failed, skipped errors. So by the time what we will do, very first thing we have to check the communication between Ansible and that servers, target servers. So Ansible server is yeah, if you are able to ping or not. If you are able to ping Ansible server or not, first we have to check. Also, authentication we have to check. Authentication. We use key-based authentication, right? In real-time projects. So authentication is happening or not, we have to check, right? And the server is shutdown state or else hung state, any issues with the server, we have to check. So every project team, what they will do before deploying on production, before applying on production, any playbook. So they will trigger on test environments. So we should not directly go to the production level, right? So first we have to test in test environments. So once it is tested, once it is success, then only we can move to the production, right? So while preparing the playbooks, we get some syntax errors, right? So even syntax errors also, yeah, while preparing the playbooks. So make sure you can manage the indentation. Instead of writing the playbook in single line, you can maintain indentation. So when we maintain indentation, issues will be reduced. The playbook errors will be reduced. Indentation means yeah. So we can break the playbook instead of giving it single line. Java playbook I showed you, right? Yeah. Instead of giving in single line, we can break up that playbook so that issues will be reduced.
Format.
Yeah, formatting.
The playbooks we need to provide to
Playbooks we need to provide to
the playbook there will be scripting.
script.
So that part we will do
We do
only.
DevOps there also only prepare that. So we get from the we have websites, right? Galaxy and modules. Ansible will provide all the examples. So you can take that and you can reuse. We don't need to prepare our own. And also GitHub also different GitHub accounts also there. So in GitHub accounts also we get all the information, playbook information. You can take from different websites and you can customize, you can reuse. As per the requirement, you can customize. Right? So troubleshooting part basically, whenever the playbook is, whenever the deployment is failed, like skipped or risked or unreachable, whenever we got that issues, by the time we can check the communication and authentication, and if any target server is down, shutdown state or hung state, that is very important here. Most of the time, commonly, the server is not reachable through like maybe network issues, network up and down issues, right? Or else authentication failure. Sometimes authentication will be failing. So we have to check that. Why this server is failing? Why this server is not reachable? We have to check and we can rerun the playbook. You can rerun the entire playbook, entire servers. Whatever servers already deployed, those will not be disturbed. Whatever servers not deployed, that will be deployed. That is nothing but idempotency. We discussed idempotency, right? Yeah, in Ansible, we we do automation, we prepare playbooks, we troubleshoot the issues. So in Ansible, we will not have any SLAs. SLAs will not be having in Ansible, right? Yeah, next one. So infrastructure management. This is the old scenario. Earlier, one IT engineer used to handle all the physical servers and the network, backup, storage management, right? So databases, server management, security management, desktop management, laptop management, whatever. One IT manager used to handle all these things earlier, right? So currently the entire things are changed, right? Like currently we are not using physical environments, right? So currently what we are doing, we are using advanced tools, which are like Terraform to create infrastructure. So we use Terraform. So by using Terraform, we can create within 1 minute whatever servers you require, how many servers you require, with all configurations, all the plugins, all the packages, all the information, right? So this Terraform is very advanced tool, right, to maintain the infrastructure. So what is the importance of Terraform here? We can create normally also. We can use main purpose is reusability. You can reuse. So for example, we created 100 servers or 1000 servers and hand over to project team. Once the project is completed, that servers you can reuse. You can move to other project and you can modify something, you can add something by using Terraform. So when we use Terraform, so here cost will be reduced, costing will be reduced. So cloud is all about costing. Even DevOps also all about costing. So wherever you can reduce the costing, you can reduce, right? So why we are doing automation? Why we require automation activities? Why the project teams are looking for automation?
Time complexity.
Yeah. So normally when we perform manual activities, there may be chances to do manual errors, manual mistakes. But when we use scripts like automation, there is no chances. There is no chance to do the mistakes here. So that is why any activity, any scripting activity, any automation activity. So before going to production, we have to test environments, right? So here main purpose is cost reduction. Automation is mainly using for cost reduction. For example, when you want to perform any patching activity, monthly patching. So in our project earlier, when we want to patch the servers, so we used to delegate nearly 10 members, 10 engineers to the patching activity. Yeah, so maximum they take 1 week to 10 days time to complete the patching activity. So every month, like that, 10 engineers dedicated to the patching activity. So that is that is costing, right? 10 engineers for patching activity. So that was the case few years ago, like 4 years back. By the time our team size 180 members, right? So, however, with the introduction of this automation tools and DevOps, cloud advanced tools, right? So we are not doing manual activities currently. We are doing automated way. So patching activity by using Ansible, we can perform in simple way. Right? Patches, every patch will be downloaded, and you can save in the tower, Ansible tower. And when we have patching schedule, by the time we can trigger the patching will be happening. In simple way, the patches will be installed in Ansible. But in real projects, earlier physical environments, so every time we have to take downtime from different teams, we have to coordinate with them, we have to download all the patches manually, and we have to apply one patches to the servers. Once we apply the patch, we can test that, right? So many things. Right? Currently, we are not doing like that. So in simple way, so by using different advanced tools, we can perform the activities, right? So Terraform is very advanced tool. It is a native cloud support. What is native cloud? What is native cloud? Primitive. Primitive. What is primitive?
It's not like having built a latest cloud. It's old, maybe.
Yeah. So native cloud means here what will happen? Terraform will support any cloud platform, right? So not only AWS, not only Azure, not only GCP, it supports any platform, right? So even Kubernetes also native cloud support, right? Kubernetes also native cloud support. You can use it any platform. Even in Azure AKS we are using, GKE we are using in Google, and EKS we are using in AWS. Even though DigitalOcean also support Kubernetes, DigitalOcean, IBM Cloud, Oracle Cloud also support Kubernetes, right? So Terraform is native cloud support. Even Azure Kubernetes also native cloud support, right? Next one. So dealing with legacy stuff, right? So when we talk about legacy stuff, it is a containerization and orchestration. What is containerization? Docker, simply. Container means Docker, right? So orchestration means Kubernetes, advanced Docker, right? So Docker and Kubernetes are very hot currently in the market. These tools are very hot, right? So if you are good in Kubernetes, you can easily crack Kubernetes, only Kubernetes. So CKA, Kubernetes engineers will write CKA certification, Certified Kubernetes Administrator, right? Yeah. So Docker and Kubernetes. In Docker, what we will do? In Docker, what we will do? We create containers and hand over to project teams. So infra activities, that is infra activity, right? In cloud, what we will do? We create servers, infrastructure, storage, network. The same way in Docker also, we create containers and we deploy the packages, required packages, and we hand over to project team. You can upload to Docker Hub, so that whoever required that, they can download and they can reuse, right? In Docker, what are the issues we face? While working on Docker containers, what are the issues we face? What are the challenges, right? So most of the time, containers will be rebooted, containers will not be accessible, containers give you slowdown issues, right? This type of issues. Yeah, so when we face any issues, container is down or not reachable or rebooted, very first thing we have to check the backend host. Host side we have to check. For example, VMware environment, VMware virtualization. The VMs are depend on physical server. If the VM is having issues, where we check that? Physical server, right? So if the physical server is having any issues, definitely that will impact to the VM, right? The same way in Docker side also, if any container is having any issues, we have to check the host, right? So host side, any issues are there, host communication is there, any errors are there, a host is rebooted, a host is in hung state, host is not reachable. This we have to check. Server, yes, right? And here, next one is Kubernetes. Yeah. So before we go into Kubernetes, see here, these are the Docker containers, ship containers, right? So these containers we can move anywhere, we can use anywhere, right? So in this containers, we deploy required packages, required databases, required applications, whatever we require. We deploy all the applications, databases, right? So this containers anyone can download and they can reuse. Even though once you run the container, if you want to edit the container, you can edit whatever you want. So this is a very lightweight environment. Lightweight environment. So in this, only bin and lib files will be created. So when we run the container, only bin and lib files, only binary library files. So if you want to deploy war file on container, we don't require full package. So why we require containers? Currently, why these containers are popular? Currently, we are using digital sites, right? Online shopping. So digital sites are very like when we book any product, that will be delivered within very short time, right? Like within 1 hour also, within 30 minutes also. So because backend there is a lightweight environment, microservices. So if you use physical environment, that will not be faster, right? So when we use Docker containers, so containers are very lightweight. We can spin up, we can do whatever we want to do. Containers, right? So these are lightweight, very faster, right? That is why. So when we place the order, like in any online shopping, so quickly that request will be placed and we'll get the product within the time frame, right? Because of backend, there are containers, lightweight environments, right? So this containers will travel anywhere, we can use anywhere. So Docker containers will run on any platform, irrespective of operating environment, right? Irrespective of service like. So it run on any flavor, any operating environment. You can run on Windows, Linux, Mac OS, Solaris, whatever platform you want, right? Next one, Kubernetes. So why Kubernetes? So we have Docker, right? Why we need to go with the Kubernetes? What is Kubernetes? Yeah. So Kubernetes is advanced to Docker. Kubernetes is advanced to Docker. In Kubernetes, we have clustering part, right? And also self-healing and auto-scaling, self-healing. That will show you in third project. How to enable the auto-healing, auto-scaling. You can see that. Okay. So here what will happen? Backend cluster will be there. Cluster means what is cluster? Group of servers. We configure as a single unit to take the to perform as a high capacity server. So number of servers will configure in the group. That group will act as a single mission, single server, high performance server, right? So if any one device, one server is down, nothing will be happen, right? So two servers are down, nothing will be happen. So cluster will handle all the applications without any manual intervention. So if any nodes like 3-4 nodes are down, so we have to check that. But single node is down, nothing will be happen. Okay? Yeah. So in Kubernetes, what we will do, we create pods. Pod concept is there, right? So pods are advanced to containers. One pod will hold single container or else more than 2 containers. Okay. So if you want to deploy the application on pod, so what we will do, we prepare some manifest files in Kubernetes. So by using manifestation, you can deploy any applications. So when we deploy any application, that will be deployed on pod. Instead of the pod, we have container. Instead of the container, the application will be deployed, right? So here, what are the issues we face in Kubernetes, right? So if any pod is down, we get some errors, right? So sometimes pods will be down, and also nodes will be down, container will be down, right? So if the pod is down, what will happen? What we will do? Again, we have to check the relevant node server. The pod is down, deployment is corrupted, manifestation is corrupted, YAML script is corrupted, pod will be down. That is one thing. And also backend node is rebooted, for example. So in the cluster, whatever nodes are there, the node is rebooted. So pod also will be rebooted. Pod will be down, right? So because pods will be deployed on nodes only, backend nodes will be there, right? Yeah, and also while deploying the application, sometimes deployment will not be accepted. It will not accept. So API server will be having some issues. API service available in Kubernetes master, right? So Kubernetes master server we have to check. When issues are having with the Kubernetes master, that we have to check, right? See here, this Kubernetes will support native cloud, any cloud platform it will support, and in Kubernetes we have clustering part. So we maintain the clusters and microservices. So in Kubernetes we require containers, right? Without containers, without Docker, Kubernetes will not work. So Kubernetes also required containers, right? So container concept is there here. Without containers, Kubernetes will not work. Fine. So Kubernetes, once you configure the cluster, once you enable the auto healing, auto scaling, so we know it involved. This will maintain. It will take care of all the things. Sometimes any deployments are failing, any cluster is down, yeah, whatever nodes are available in the cluster. If any nodes are down, by the time we have to involve. Okay.
So auto healing in the sense auto troubleshooting.
Auto healing means automatically it will troubleshoot. Yes. For example, one pod is down. Whatever pod is down, backend storage will be there. Storage means persistent volumes. We attach persistent volumes. So in that, all the application data will be saved. So whatever pod is corrupted, in place of that, Kubernetes master will create one more pod and it will take the backup from volumes, persistent volumes. It will recreate the pods. Whenever pods are corrupted, pods are down. Right? So when we enable auto scaling, auto healing, so automatically it will recreate the pods, it will recreate the containers, right? So it will maintain your application upon running time. Right?
So when it creates new part,
Hmm.
then will it also delete the existing part which is having issue?
Not like that, actually. For example, so we selected 10 pods and configure the auto healing. If the 10 pods are having any issues, definitely, so Kubernetes master will take it. If the pod is down or corrupted or anything happened, right? So other pods, when you create, for example, you created 2 more pods, right? So you have it enable auto healing. That will work individually. The pod is down, we have to check manually. But when the auto healing is available, enabled, so definitely Kubernetes master will take care of the issues. In Kubernetes master, one component is there, right? Which is controller manager. Controller manager will monitor the failures. If any failures are happening, so controller manager will take the information from etcd and it will recreate the pods and it will configure the pods. That will be happen automatically. So because when we deploy any application, we don't deploy on single pod. We deploy on 3 pods or 5 pods. If any one pod is corrupted, nothing will be happen. So meanwhile, auto healing will replace that failure pod, right? So like that, Kubernetes will maintain your infrastructure. Fine.
Auto healing and self healing both are same.
Sorry, self healing. Yeah, both are same. Correct.
Okay, thank you.
Next one, monitoring and removing bottlenecks. What is bottleneck? Yeah, for example, so we are handling one cluster. In the cluster, we have 10 servers are there. 10 server. In the 10 servers, we are deployed some applications, right? So if one server is down, nothing will be happening. 2 servers are down, nothing will be happening. So 5 servers are down at a time. Some impact will be happening. Bandwidth issues will be happening. By the time slowly, bottlenecks will be happening. So if you are not troubleshooting, if you are not enabling other servers which are failed, so maybe after some time cluster will be down because so overburden will be happening in the more load will be happening in the cluster. Whatever servers are running, that service will handle all the load. So by the time what will happen? Maybe it will give you crashes. Will cluster may be crashed. That is why whatever issues happen with the servers that we have to resolve. So immediately we bring back to original state, right? So for example, for example, 10 team members are there. 10 team members are there. Team members, right? So normally in real-time projects, workload will be distributed equally. Workload will be distributed equally. We know, right? So 5 members are going on leave. What will happen? They will come after 1 month. So actually, we delegate the work to 10 members. 5 members are going on leave. They will come back after 1 month. What will happen? Overloaded, right? 10 members will get overloaded. The same way, in cluster level also, if any nodes are down, whatever nodes are running, those will get overloaded. By the time bottlenecks will be happening. Okay, so 5 members are handling all the activities in the project, right? 5 members already gone, they are gone on leave. 5 members are handling. One person is taken sick leave. Other person also having some emergency. 3 days are there. They cannot handle. Some escalations will be happened. Some user escalations will be happened. Client escalations will be happened. By the time everyone will be in trouble. The same way server level also same. Cluster, when we configure cluster, so if any nodes are down, immediately we have to troubleshoot and we have to bring back to original state. Otherwise, yeah, some point of time cluster may be crash or down, right? So that we get some issues. If the cluster is down, business will be impacted. So client will escalate, right? So that is why cluster should be maintained properly. So if any issues happen, immediately we have to resolve the issues. Here, so what it is saying here, leverage technology to remove bottlenecks in workflow. We have to leverage the technology, right? Next one, documentation. What is documentation? You know very well, right? Yeah. So in real-time projects, we prepare SOPs. SOPs, right? Standard operating procedures. Every activity we prepare SOP in real-time projects. For example, you are working on some new issue. Immediately we create one document in real time. Everyone will create the documents and they will save in central repositories, right? So this documentation is very important. So most of the project teams, they will maintain SOPs. For example, one DevOps gets joined into the project. What we will do? We give the share folder access. Whatever documents we save in the share folder, that documents we share with the new member. So initially, when they are getting KT, by the time they follow the documentation, right? Documentation is very important. So in my previous project, so we prepared all the documents. So if anyone want to create EC2 instance, even EC2 instance also one document is there. Even snapshot also one document. Like that. Every activity, patching activity, automation activity, and deployment activity, every activity we prepared documents. So simply you guys can refer the documents. For example, the person is in night shift. Only one person is handling the shift. So midnight, so no one will available, right? So by the time they can refer the documentation, right? So documentation is very important. Yeah, to handle the issues and the activities. So whenever we work on any activities, so everything should be documented here. We have to prepare some documentation, right?
So nowadays is Terraform being used by everyone.
Yeah, Terraform. Most of the project teams they're using Terraform. 90% of the projects. 90%.
So in the case, in which cases we log into this cloud servers, I mean cloud services, can be AWS, because we most of the things we can do using their accounts.
Yeah. So in our previous project, yeah, Terraform was there. Terraform was there. Sometimes, yeah. In the platform, cloud platform, issues, we troubleshoot issues, right? We troubleshoot issues, right? We have to log in cloud platform. So for example, user issues. User is unable to log into the server. User is unable to access the storage, S3 battery. And also one user is having some IM issues, IM account issues, account lockout. So by the time you have to log in, right? Yeah. Next one. Yes, here create SOPs, standard operating procedures. So every activity we create some document SOP, right? Yeah. After that, training and self-development. So this is very, very important, right? So trainings, whatever trainings we are getting, whatever trainings are happening in the project, so that we can attend. So we should not miss the trainings. Initially, when I started my career, by the time architects, managers, they used to give some trainings. By the time I used to attend all the trainings, whatever trainings relevant to our project, whatever trainings they gave. So I used to attend. So when I switched to Kubernetes, when I switched to DevOps, I used to give trainings. So I used to give trainings like Jenkins training, I gave AWS training, I gave classroom training, 5 days training, 3 days training, 2 days training like that, and Docker training, Ansible training, Kubernetes training. I gave so many times. When I give training, so people like from freshers to directors, VPs also, they used to attend. And like that, so architects, managers will give trainings in real projects. Okay. So when we get a chance to attend the trainings, we should not miss them. Right. So trainings and self-development. So this is very important for everyone, every technology, not only for DevOps, not only for cloud, so every technology. So we have to improve our skill sets. So in DevOps, what will happen? Automation activity, right? So automation activities, every time we should not do repeated way. We do something special. We do something different, right? So if we are doing same activity repeatedly, same things, our growth will not be move forward, right? That is why. So we have to do in different way. So for example, one senior guy is there, 10 years, 12 years guy. Also fresher is there. Fresher is doing same activity, senior also doing same activity. There is no difference. What will happen? That is, yeah, that will be effective senior, right? That is why we have to do in different way.
Different ways in also writing the scripts.
Means yeah. So we have to handle different activities. We have to work on different way. Like so, we have to showcase our skill sets as per your experience. Multitasks, handling client requirements, gather the requirements, and work on major activities. Right, getting approvals. Right. So this is very important for any technology. So training and self-development. Fine. So when I started my career as a admin, by the time admin was in 2005, I started my career in Verizon Data Services, one of the MNC product company. So by the time I used to handle storages, EMC storage, NetApp storage, right, Apache storage. By the time storage is very core technology by the time, not now, right? So we used to handle complete project data. In the storage only the data will be saved, right? So by the time it was very high demand. Slowly, what happened here? Slowly, even a fresher also used to handle that. So yeah, by the time I was realized and I moved to cloud and DevOps. So if you are doing same activity repeatedly, even though freshers and you also doing same activity, so you will be, yeah, some point of time you will be monitored. So you will be pointed, right? That is why we have to perform in different way. Whatever activities you are doing, those we can do in differently. Definitely, our growth will be more like that. Fine. So these are the things available. So this 10 points are very important, right? To work on the roles, automation roles, cloud roles, right? Fine. Yeah. Tomorrow we'll work on first project, which is CI/CD project. That will take 1 hour 15 minutes to 1.5 hours. Same timing we will connect. Same timing, 8 to 8 o'clock we connect. Okay?
Sir, hello.
Yeah. Go ahead. Yes.
Sir, you didn't teach past last in uh, last session, sir.
What is that? Bash.
Sir, Azure, in Azure, you didn't teach past last.
Pass. Platform as service. We discussed, right?
Yes, sir.
We discussed already, right? Platform as service, IaaS as service, and software as service. We discussed already. Just go to the video. You will understand.
Okay, sir.
Fine. Yeah. Tomorrow we'll work on first project, which is CI/CD project, and on Monday we'll work on ticketing tools. Ticketing tools, right? What are the ticketing tools are popular currently? Like popular tools are ServiceNow, Jira, and Remedy, Jitbit. These are the popular tools. We'll work on one tool which is ServiceNow. I'll show you screenshots, but ServiceNow is not is licensed. Yeah. Official sites should not official things should not showcase. Okay. Yeah. So I'll show you some screenshots and I explain step by step. Okay. And
Sir, can you send Azure documentation, sir?
yeah, I'll forward today. Yes. And then Tuesday,
And Ansible documents also you have not shared yet.
full document. Yes. I'll show
Remaining are shared, but like on basis.
Ansible and Azure, right? Yeah, definitely I'll share today. And yeah, tomorrow we'll work on first project. Day after Monday we'll work on second project, which is migration project. And Tuesday we work on no. Monday we work on ticketing tools. Tuesday we work on second project. Wednesday, third project. Thursday, scripting language. So Python. Yeah, that is Python. Yes. Thursday mostly we'll try. Okay. Yeah. Fine. So we stop here. Yeah. Tomorrow, make sure you can attend that session, which is very important. CI/CD completely development to production deployments. So we'll perform in live. You see that flow in live. Okay. Yeah. So we stop here. Fine. Thank you all. Thanks.